Picture this. You are having an absolutely terrible day. It is somewhere around 12,000 years ago. You are in what is now the region of the Middle East, and things have gone wrong in a sequence of small, compounding ways that would feel remarkably familiar to anyone who has ever had one of those days where the universe seems personally invested in your frustration. You gathered some wild grain earlier, you ground it up, mixed it with water, and left the paste sitting near the fire because you were planning to cook it later. Then something happened. An animal needed chasing, or a conflict needed mediating, or you simply fell asleep because hunting and gathering is exhausting and nobody is going to judge you for that. The paste sat there longer than intended. Maybe it rained and the mixture got wetter than you wanted. Maybe wild yeast floating through the air, which is everywhere all the time, and which you have absolutely no knowledge of whatsoever, landed in your grain paste and started doing what yeast does when it encounters carbohydrates in the presence of moisture, consuming sugars and releasing carbon dioxide and alcohol as byproducts. When you come back to your grain paste, it has changed. It looks different, it smells different, a sharper, slightly sour, almost alive smell that was not there before. It has bubbled slightly and expanded in a way that paste does not normally do. A reasonable person in your position, which is a person with no food safety regulations, no alternative dinner options, and a practical relationship with the reality that wasted food is a serious problem, makes a decision. You cook it anyway. And something extraordinary happens. The heat sets the structure created by those tiny bubbles of carbon dioxide. The paste becomes something new, something with texture and chew, and a complex flavor that the original grain and water combination did not have. It is warm and filling, and unlike anything you have eaten before. It is, by any meaningful definition, bread. And you made it by accident on a day when everything else was going wrong. This is approximately how one of the most important foods in human history was discovered, and the actual story, layered with archaeology and chemistry and the particular genius of human beings who figured things out by paying close attention to what happened when they made mistakes, is considerably more fascinating than even that scenario suggests. Start with the grain, because understanding what grain is and what it represents in human history is foundational to understanding how bread happened. Wild grasses producing edible seeds have existed for millions of years, long predating any human interest in them. The ancestors of modern wheat, barley, rye, and other cereal crops were growing across the landscapes of the Middle East, North Africa, and parts of Asia in wild forms that produced seeds as part of their reproductive cycle. These seeds, the grains that would eventually become the foundation of human agriculture, are remarkable pieces of biological engineering. Dense packages of carbohydrates, proteins, and fats surrounded by protective husks designed to survive in soil long enough to germinate and produce a new plant. For most of human prehistory, wild grains were a secondary food source. Hunter-gatherer groups did eat them when available, but the effort required to collect enough wild grain to be nutritionally meaningful was considerable. Wild grain plants scatter their seeds when ripe, which is adaptive for the plant but deeply inconvenient for anyone trying to harvest them in quantity. The seeds themselves require processing to remove husks and make the nutritional content accessible, and the caloric payoff per unit of effort compared to hunting large game or gathering calorie-dense plant foods like tubers and nuts was not always competitive. And then, sometime around 23,000 years ago, something in the archaeological record changes. At a site called Ohalo II, a remarkably preserved hunter-gatherer camp submerged in the Sea of Galilee in what is now Israel, researchers have found evidence of grain processing on a scale that significantly predates the agricultural revolution. The site, dated to approximately 23,000 years ago, contained ground stone tools, the remains of wild grain, and evidence of structured food preparation that suggests grain was being deliberately processed and consumed as a significant dietary component thousands of years before anyone started farming. This pushes the beginning of the grain story back much further than the conventional narrative of agricultural origins, and it raises an important question. What were people doing with grain for those thousands of years between the first evidence of serious grain processing and the development of farming? The answer is that they were experimenting, observing, and gradually accumulating the knowledge that would eventually make bread inevitable. The chemistry of what happens to grain during processing and cooking is worth understanding, because it is the chemistry that makes bread possible, and that explains why ancient humans would have been drawn to cooked grain products over raw ones. Raw grain seeds are nutritionally available, but not optimally so. The starches in grain are present in a form called resistant starch, which human digestive systems process less efficiently than cooked starch. Cooking grain, even in its simplest form of dropping seeds directly into fire or onto hot stones, triggers a process called gelatinization. The starch granules absorb water, swell, and rupture, converting the resistant starch into a form that the human digestive system can access much more completely. This matters enormously from a caloric perspective. Cooking grain makes significantly more of its nutritional content available to the person eating it. Richard Wrangham, a primatologist who developed what he calls the cooking hypothesis, has argued that cooking, including cooking of starchy plant foods, was a pivotal development in human evolution, because the increased caloric availability from cooked food supported the expansion of the metabolically expensive human brain. Whether or not you accept the full scope of that argument, the basic chemistry is not contested. Cooked starch is more digestible than raw starch, and the difference in accessible calories is significant. Ancient humans who discovered that cooked grain tasted better and was more satisfying than raw grain were discovering something real about their biology, even without any theoretical framework for understanding why. The experimentation that followed was driven by observable benefit. The cooked version was better, so people kept cooking it and kept observing what happened when they varied the conditions. The first processed grain products were almost certainly not bread in any sense we would recognize. They were likely gruels and porridges, mixtures of cracked or ground grain and water cooked over heat until the starch gelatinized into a thick, digestible mass. This is the simplest possible grain preparation, requiring only the ability to grind grain into smaller particles, water, and a heat source, and versions of it appear across virtually every grain-eating culture in human history. The step from porridge to flatbread is conceptually small but practically significant. If you cook your grain paste in a thin layer on a hot stone rather than in water, the water evaporates and the starches set into a solid structure that can be picked up, carried, and eaten without a vessel. Flatbreads are essentially portable porridge, and they represent an enormous practical advance over gruels because portability matters enormously to people who move around. Archaeological evidence for early flatbread production comes from sites across the Middle East and North Africa. Charred remains of cooked grain products have been found at multiple sites, and the analysis of their structure using techniques including electron microscopy can distinguish between porridge-type preparations and bread-type preparations based on the cellular structure visible in the charred remains. The most dramatic evidence came in 2018 when researchers announced the discovery of charred flatbread remains at a site called Shubaika, one in northeastern Jordan, dated to approximately 14,400 years ago. These remains, made by a people called the Natufians, who were hunter-gatherers with a sophisticated relationship with wild plants, predate the development of agriculture in the region by roughly 4,000 years. The Natufians were making flatbreads from wild grain long before anyone was farming grain, which means that bread was not a product of agriculture. Agriculture may, in part, have been a product of bread, or at least of the intense human investment in grain that bread making represented. The Natufians deserve extended attention because they occupy a fascinating position in the story of how ancient humans accidentally discovered bread, and then spent thousands of years refining what they had found. The Natufian culture flourished in the Levant region between roughly 15,000 and 11,500 years ago, during the period immediately before the development of agriculture. They were not farmers, but they were not simple nomadic hunter-gatherers in the conventional sense either. They built semi-permanent structures. They had cemeteries with deliberate burial practices. They used groundstone tools extensively for processing plant foods. They harvested wild grain in sufficient quantities to store it, which is evidenced by the presence of storage facilities and the granary pests whose remains have been found at their sites. The Natufians were doing intensive wild plant management that stopped just short of deliberate cultivation, and their relationship with grain was sophisticated enough to produce bread making several millennia before anyone planted the first wheat field. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. They were also almost certainly the people who first encountered fermented grain products, because anyone working with grain and water in the volumes the Natufians were processing would have regularly and unavoidably encountered the effects of fermentation. Wild yeast is everywhere. It floats on air currents, it lives on the surfaces of grain seeds, it colonizes any moist carbohydrate-rich environment it encounters. A grain storage facility in the Natufian world would have been a yeast paradise, and any grain paste left for longer than intended would have been colonized by wild yeast within hours under the right temperature conditions. The Natufians would have encountered fermented grain regularly, and the question is, what they did with it. The answer, based on archaeological evidence and the basic logic of human curiosity and practical need, is that they observed what happened, noticed that cooked fermented grain paste was different from cooked non-fermented grain paste, and began, over generations of observation and experimentation, to understand how to produce the fermented version deliberately. Here is where the story of bread intersects with one of the great ongoing debates in the archaeology of fermentation. Which came first, bread or beer? The question is less absurd than it sounds. Both bread and beer require the same core ingredients: grain, water, and yeast. Both involve fermentation by wild or cultivated yeast. Both were discovered in the same general time period and geographic region. The question of which one came first, or whether they were discovered simultaneously as different expressions of the same underlying fermentation process, has generated serious scholarly debate because the answer has implications for understanding what motivated ancient humans to invest so heavily in grain. The beer first hypothesis, associated with archaeologists including Patrick McGovern, argues that the desire for fermented beverages may have been a significant driver of early grain intensification. The logic is that fermented beverages have psychoactive effects that made them valuable for social, ritual, and medicinal purposes, and that this value may have provided stronger motivation for the intensive grain processing that characterized pre-agricultural groups like the Natufians than the production of bread alone would have. The bread-first hypothesis argues that the caloric and practical benefits of bread as a portable, storable, filling food source made it the more plausible primary motivation for grain intensification, and that beer was a secondary discovery made in the course of bread production. The most honest current answer from the archaeological evidence is that the distinction may be somewhat artificial. Both products arise naturally from the same fermentation processes operating on grain and water. A group regularly producing grain porridges and flatbreads would encounter fermentation regularly and would observe the full range of fermentation outcomes, from slightly soured paste suitable for bread to fully liquefied fermented grain beverages. The discovery of both was probably simultaneous and overlapping rather than sequential, with different groups emphasizing different products based on their particular circumstances, preferences, and uses. The development of leavened bread from flatbread involves the specific discovery that fermented grain paste, when cooked, produces a lighter, airier, more texturally complex result than non-fermented paste, and that this effect can be deliberately reproduced by maintaining a living culture of fermenting organisms and adding it to new grain paste. The sourdough starter, which is what this maintaining of a living fermentation culture produces, is one of the oldest human biotechnologies. A sourdough starter is a self-perpetuating community of wild yeasts and lactic acid bacteria that consume the carbohydrates in grain flour, producing carbon dioxide that creates the bubbles responsible for the rise in leavened bread, and organic acids that produce the characteristic sour flavor. Once established, a sourdough culture can be kept alive indefinitely by regular feeding with fresh flour and water. The discovery that fermented grain paste cooked into a superior product to non-fermented paste was almost certainly made many times by many people before anyone worked out how to reliably reproduce it. The challenge is that wild yeast fermentation is sensitive to temperature, hydration levels, the specific microbial community present in a given environment, and the composition of the grain being used. Early bread makers would have had inconsistent results, sometimes producing beautiful risen loaves, and sometimes producing flat, dense products, without initially understanding what variables were responsible for the difference. The accumulation of knowledge about how to reliably produce leavened bread, including the management of a starter culture, the recognition of visual cues indicating adequate fermentation, the correct hydration levels for different grain types, and the heat management during baking happened over generations of observation and refinement. This was empirical science conducted without any theoretical framework, driven purely by the observation that certain practices produced better outcomes, and that those practices were worth understanding well enough to repeat deliberately. The development of clay ovens, called tannoors, or similar names across Middle Eastern and Central Asian cultures, represented a technological advance that dramatically expanded what was possible in bread production. An enclosed clay oven reaches higher temperatures than an open fire, maintains those temperatures more consistently, and creates a humid baking environment from the moisture evaporating from the dough that produces the characteristic crust formation of baked bread. The transition from cooking flatbreads on hot stones to baking leavened dough in enclosed clay ovens is documented in the archaeological record across the period from roughly 9,000 to 6,000 years ago, corresponding to the period when settled agricultural communities were expanding across the Middle East and Mediterranean. As communities became more settled, the investment in fixed cooking infrastructure became more practical, and the results justified the investment dramatically. Baked leavened bread in a proper oven is a categorically different food from a flatbread cooked on a stone. It is lighter, more digestible, more texturally complex, more flavorful, and more satisfying in a way that the people producing it would have recognized immediately. The discovery was not subtle. When you bake a properly fermented dough in a hot, enclosed oven and it emerges as a risen, golden, aromatic loaf, the response is not confusion. It is the response that bread has produced in every human who has encountered it for the last 10,000 years. The agricultural revolution and bread are intertwined in ways that continue to be debated, but the most current evidence suggests the relationship is more complex than the conventional narrative implies. The conventional story is simple. Humans developed agriculture, began growing grain in fields, produced grain in quantities that made bread making practical, and bread followed from agriculture as a product of agricultural surplus. This story has the arrow of causation pointing from agriculture to bread. The emerging picture from recent archaeology is considerably more interesting. The evidence from sites like Shubeika 1 showing bread production before agriculture, combined with increasing evidence that grain processing and storage were intensive activities for hunter-gatherer groups before farming, suggests that the relationship between bread and agriculture may run in both directions. The human investment in grain that bread represented, the accumulated knowledge of grain processing, the development of grinding tools, storage facilities, and cooking technologies oriented toward grain may have been part of what made the eventual development of deliberate grain cultivation attractive and thinkable. People who were already managing wild grain intensively, already building storage facilities, already investing in grinding stones, already developing the cultural knowledge associated with grain processing and fermentation, were people who had practical and cultural reasons to want more grain more reliably than wild harvesting could provide. The step from intensive management of wild grain to deliberate cultivation of selected grain varieties was smaller for people who were already heavily invested in grain than it would have been for people encountering grain as an occasional supplementary food. In this reading, the discovery of bread and the development of agriculture are not simply sequential events where one produced the other. They are entangled developments emerging from the same intensifying human engagement with grain, reinforcing each other over thousands of years until both became foundational elements of the agricultural civilizations that would shape human history. The spread of bread across human cultures following the agricultural revolution was rapid by the standards of the ancient world and reflects both the practical value of bread and the ease with which bread knowledge transferred between communities. Bread made from emmer wheat and einkorn, the earliest domesticated wheat varieties, was a staple food across the ancient Middle East by 8,000 years ago. By 6,000 years ago, bread production is documented across a wide geographic range from Egypt to the Indus Valley. By 4,000 years ago, leavened bread was a sufficiently important commodity in Egypt that it appears regularly in tomb art, in administrative records, and as a form of worker compensation. Egyptian workers building monuments were partly paid in bread and beer, the twin fermentation products that had become indispensable to settled civilization. The particular conditions of the Nile Valley made Egypt an extraordinary center of bread culture in the ancient world. The Nile's annual flooding deposited rich silt across the floodplain, producing wheat harvests of exceptional abundance. The warm, humid Egyptian climate was hospitable to the wild yeasts that drove fermentation. Egyptian bakers working with abundant grain and favorable fermentation conditions developed techniques and bread varieties of considerable sophistication, with evidence from ancient sites suggesting they produced dozens of distinct bread types varying in flour fineness, fermentation methods, shaping, and baking conditions. The ancient Greeks and Romans inherited and extended the Egyptian bread tradition, and Roman bread production reached an industrial scale that represents one of the most impressive food production achievements of the ancient world. At its peak, the city of Rome was supplied by a network of professional bakers using large millstones driven by water or animal power to produce flour in quantities that supplied a population of over 1 million people. The Roman state distributed free grain to a significant portion of the city's population, and the conversion of that grain into bread was a daily activity of enormous social and economic importance. Here's the thread that runs through this entire story and makes it worth telling beyond the specific history of one food. The discovery of bread was not a single moment of inspiration. It was a process spanning thousands of years, driven by the accumulation of observations made by people who paid close attention to what happened when ordinary things went slightly wrong. The grain paste left too long near the fire, the porridge that sat overnight and smelled different in the morning. The flatbread made from accidentally fermented paste that rose when cooked in a way that the unfermented version did not. Each of these observations, made by individuals who had no theoretical framework for understanding what they were seeing, but who had the practical intelligence to recognize that something interesting had happened, was a building block in the construction of one of humanity's most significant food technologies. The people who discovered bread were not scientists. They did not have theories about yeast or fermentation or starch gelatinization. They had eyes and noses, and the consistent human capacity for noticing when something unexpected produces a better outcome than the expected one. They had the practical wisdom to repeat what worked and the patience to accumulate knowledge across generations in the absence of writing or formal instruction. The sourdough starter kept alive in a clay pot in a Natufian settlement is the same fundamental technology as the sourdough starter kept alive in a glass jar in a modern kitchen, practiced by people who now understand the microbiology that the Natufians were managing entirely by observation and intuition. The knowledge has deepened enormously. The technology is essentially the same. Every loaf of bread that exists today, from the most artisanal hand-shaped sourdough to the most industrially produced sliced white, is a direct descendant of what happened when someone 14,000 years ago came back to their grain paste after a longer absence than planned, cooked it anyway, and discovered that the mistake tasted better than the original plan would have, which is, when you think about it, one of the most human things that has ever happened.